Hi everyone, welcome to my channel. Today, we're going to be testing USB over UTP cable C. So instead of using a traditional USB connector, we're going to use a keystone jack, which is also known as a UTP jack or an Ethernet jack. We're going to be powering a Raspberry Pi 4 with 5 volts and 2 amps over this UTP cable. And then we're going to test the voltage drop as well as the transfer speed. So why would you want to do something like this? Well, let's say that you have some equipment that has an Ethernet port and it needs power. Instead of having to run another power cord over to that device, you can just use your existing Ethernet cable and that will work. For example, a wireless access point. A lot of them have an Ethernet port on the back where you can plug in power. But if you don't have a wall outlet nearby, you can just use a UTP cable running from your switch over to the access point to get power. Now there are a couple of different ways to do this. You could actually buy a special keystone jack that has a USB signal on the inside and a ground on the outside, and that will allow you to pass through power and data. But I decided to go with a different method. Using an external power supply, and I am using a commercial off-the-shelf USB to UTP adapter. Now there are many different types of these adapters out there, and they very inexpensive. So, I think I got mine for like $15. But this one requires 2 unshielded twisted pair wires and then a ground. So the first thing I want to do is test the voltage drop. To do that, we're going to be using this Fluke 17 BNC VTs, which is a non-contact voltage tester. It works up to 1000 volts AC and 750 volts DC. And this is very helpful because we won't have to break our circuit to check for voltage. So we'll just move this across the UTP cable, and it shows that we have voltage. Now we'll test for voltage drop. We'll start by measuring the voltage at the power supply. So here we have 12 volts, and then we measure the voltage at the other end of the cable, and we have 11.58. So we're seeing about 420 millivolts of voltage drop. Now, that might seem like a lot, but keep in mind that this is a very long cable. This is probably around 100 meters of cable. Now, according to Ohm's law, voltage equals current times resistance. If we keep the current low like 2 amps, then we should have very little voltage drop. But if we try to increase the current maybe to 5 amps, then we're going to see a larger voltage drop. Now for this particular cable, the manufacturer states that you can run up to 5 amps. So now we'll test for voltage drop with the load connected to the Raspberry Pi. So once again, we have 12 volts at the power supply, and then we check the voltage at the other end, and we still have 11.6 volts. So we're still only seeing about 400 millivolts of voltage drop. That means that this cable can easily support 2 amps over a very long distance. Now that we know that our voltage drop is acceptable, we can proceed to testing the transfer speed. Now we're going to be using this OWC Envoy Pro FX USB 3 expansion chassis, and this is connected via USB 3 to our Raspberry Pi. Inside of this enclosure, we have an SSD that is connected via USB 3, and now we can test the transfer speed. crystal disk mark, and we re-getting a read speed of over 200 megabytes per second and a write speed of about 120 megabytes per second. See? So it looks like our transfer speeds are good. But how about if we connect a load directly to the Raspberry Pi? See? So we LO disconnect the external enclosure, and now we LO connect our SSD directly to the Raspberry Pi. Now we'll run crystal disk mark again, and we're seeing almost identical results. So it doesn't matter what kind of load you connect to this. Whether it's a direct attached device or a device that's connected via USB hub, the transfer speed remains the same. The next thing we are going to do is test the latency, and to do that we are going to be using this iometer utility. So we'll run iometer, and then we'll select our next. We'll set the number of threads to 1, and the block size to 4000. The block size represents the size of each individual request, and the number of threads represents the number of concurrent requests. For this test we are going to be doing 1 million operations, and we LLB testing both read and write speeds. So now we LO run the test, and it took 1 minute and 2 seconds to complete 1 million read operations, and we getting a very low average latency of 33 microseconds. Next, we'll do a write test with 1 million operations. It took 1 minute and 16 seconds to complete, and we getting an average latency of 20 microseconds. Now this is a very fast SSD, so the actual latency is going to be a lot lower than this. But this is a good representation of what you can expect if you were to run iometer on your system. The next thing we're going to do is test a longer transfer. We're going to generate a file that is 10 gigabytes in size, and then we copy that file from one directory to another. We'll use the time command to measure the time it takes to complete this operation. So here we have 10 gigabytes worth of random data, and it took 3 minutes and 12 seconds to complete the transfer. So this is a pretty fast transfer speed. If we look at the bitrate, we're transferring about 3.3 gigabits per second. Now remember that our cable is rated for 10 gigabits per second. So this is well within spec. Now we did notice that the transfer speed slowed down towards the end. This is probably due to the fact that our Raspberry Pi is only capable of about 400 megabytes per second sustained transfer speed. Now that we've tested all of the different aspects of this setup, we can talk about some of the pros and cons. First, let's talk about the pros. First of all, it's a very clean setup. There's no extra cables or connectors that you have to worry about. Everything is contained within the Keystone GAC. Another advantage is that it allows you to power devices that don't have their own power supply. Now let's talk about some of the disadvantages. One disadvantage is that you're limited to the length of the cable. If you use a very long cable, you're going to experience more voltage drop, and you're going to see a decrease in transfer speed. Also, if you use a cheap cable or a cable that isn't rated for USB, you could experience data loss. Another disadvantage is that it's not very flexible. So if you need to bend the cable a lot, it could start to break down over time. Now, here's an interesting question. What happens if we remove the ground? So we'll unplug the green wire, and now we'll try to boot up our Raspberry Pi. So it looks like our Raspberry Pi is now powered off. If we check the voltage, We no longer have any voltage. So the ground is necessary for this to work. Next, we'll restore the ground wire, and we'll try to test the transfer speed without the shield. Now we'll run crystal disk mark, and it looks like we're getting a lot of errors. See. So it looks like the shield is necessary for data integrity. Now we're going to test the voltage drop again with the load connected to the Raspberry Pi. Now we'll add a 10 GB file transfer and see if we get any errors. Kuma. So we'll wait until the transfer completes, and it looks like we have an error. Shield. So it looks like the shield and the ground are necessary for proper operation. You might be wondering, why does this even work in the first place? The reason is because the USB protocol is designed to work over twisted pair cable. In fact, you can buy a USB over UTP cable directly. But these cables are usually shielded. Unshielded twisted pair cable is commonly used for Ethernet runs under 100 meters, and it is typically shielded when it is used over longer distances. The shielding helps to reduce electrical interference, and it also provides a ground reference. See. So you shouldn't use a non-shielded UTP cable for this application. Kuna. Now if you decide to make a USB over UTP adapter yourself, you can find detailed instructions online. Just be sure to follow the instructions very carefully and use high-quality parts. Well, that concludes our experiment with USB over UTP cable. I hope you guys enjoyed the video, and I'll see you in the next one. Thank you for watching. If you enjoyed the video, please consider subscribing.